The equipment being used for this process is specialized for this type of application. The first item being rolled off the truck is a 13 kilowatt 50 amp generator with 3-inch 50-foot long hose, a 110 volt 3-motor dust collector, and an 840 pound 6-tool rotary. Because this is bigger than the other stuff, it's getting winched down the ramp out of the van to the floor. The process is meant to reduce any elevation inequalities that exist in the concrete slab. Reason being is because the coating system that's being applied is going to be a total of no more than 20 mils. This means any elevation inequality that the floor has will telegraph through if it exceeds that 20 mils. It also will contribute to premature wear because as the floor is trafficked, any high spots are going to catch the amount of traffic going across it, and that will, of course, wear the coating prematurely. The grinding process is pretty straightforward. It's just a matter of finding the high spot and then running the grinder across it until the high spot is reduced to the elevation that surrounds it. The objective is not necessarily to make the floor completely flat, which is going to take much longer and be a much more expensive process to do, and quite honestly, for a coating, it's unnecessary. The goal is simply to reduce those abrupt elevation inequalities that would be wear points for traffic. And also the floor will look better. Any light reflection, of course, will be straight and more orderly looking than if the floor was wavy. In this particular instance, the slab on the left is higher than the one on the right. A little dampening of the surface and the aggregate exposure gives an idea how much had to be removed to equalize the difference between the two slabs. This overall slab joint was approximately 40 feet long, so the majority of this process is just taking down the one side of the high slab. The dust trail that's left behind from the grinder also gives an idea of which side is being cut more than the other. In this case, the closest side is the high slab. This is the same joint, just on the other side of the building. On the right-hand side, that side of the slab is high, and on the left is low. To give an idea of the amount of removal that's taking place after just an hour of grinding, there's this much dust from the concrete that's been removed. So it gives a good idea how much concrete has to be removed in order to equalize the joint between the two slabs. And that's the basic process. Finding the high spot, in this case it was obvious because it was practically a tripping hazard, running the grinder over it subsequent times until it is flat enough with the opposite side, and reducing that elevation inequality. Because again, as this floor is trafficked over that coating, any high spot is going to be a wear point. And anybody that knows coatings is that once the coating starts to chip and crack at any given spot, it's only going to get worse from there. So the main aim here is to flatten any of these elevation inequalities so that the coating will look better and, of course, wear better. And that's about it. In just under 2 hours, 60 linear feet of joint has been flattened. Though all the joint wasn't exactly the same as far as the elevation inequality, overall the joint is more flat, which is going to help that new coating that's going to be installed next.